what if your line is not in y equals mx plus b form? What if it is in some other form? One other form of a line is called point slope form. And this is where m is still the slope, but this time we're given some point on the line, which we're just calling x1, y1. So in this case, this is called point slope form. Let me write that, point slope form. Now, one option is if you're given point slope form, you can multiply it out and make it look like y equals mx plus b. But sometimes I don't know the b, I don't know the y-intercept, and we know some other point. That's when this is really useful. So this x1, y1 is the other point we know, and we always need to know slope. But they're jumping us into an equation that doesn't even give us slope. So we also need to review the formula for slope, which is y2 minus y1 over x2 minus x1. And this is actually why they use x1 and y1, is because that's already part of the slope formula that hopefully is ringing some bells from an algebra class in our past. But we're going to try it. What we mean by x1, y1 is just the first x value and the first y value. And x2, y2 means the first or the second x value and the second y value. So we're going to just plug in these four numbers into that slope equation, and then we'll worry about find the equation of the line. First, we have to find that m. All right, so m equals the second y value, 0, minus the first y value, 5. Not sure why I made that line so long. All right, then the bottom of the fraction is the x's subtracted. Second x value minus first x value. So what I'm getting here is -5 on the top and 7 on the bottom. So that is our slope. If we were graphing, it'd be down 5 over 7. But we're not graphing on this one. We are using this point slope form. So I put in y equals, oh, and I didn't mention here that x and y are the variables. I don't plug in for the plane x and the plane y here. We're only plugging in the point where it's x1, y1. I know there's a lot of x's and y's floating around, but remember, we're sort of aiming for a y equals mx plus b kind of form. So in this case, we want y to be there as a variable. Then -5/7 x minus x1, the first x value, so x minus 7. And then plus y1, the first y value, 5. Now, it actually didn't matter which x and y we pick. The same equation works if we use the other point, x minus 14, and then plus 0. So these are the same line, but the way to check is to get it in y equals mx plus b. So let's actually do that. I just distribute. So in this case, I'd get y equals -5/7 x. If I do -5/7 times -7, the negatives cancel and the 7s cancel. So we end up with just +5 plus 5. So y equals -5/7 x plus 10. Right? Divide by 7, multiply by 7, cancels, the negatives cancel too. All right, let's see if we get the same thing here. I distribute the -5/7. So y equals -5/7 x. Well, 14 divided by 7 is 2. So it's -5 times -2 is plus 10 plus 0. Oh yeah, plus 0 is not changing that. So it's definitely the same line. We can use either point and we get the same line from point slope form. All right, so hopefully that's a good review of how to find slope, how to use point slope form, but let's complete this chart and make sure we're getting it. So here's some equations. we're supposed to just look at the equation and know what's the slope and what point is there. Now, what is sometimes a little tricky is that we have to flip the sign of x after x, because in parentheses is x minus x1. So in this case, the slope, we just leave it the same sign, -3/4. But the x value of the point is going to have that flipped sign, so it's going to be a +5. Right, just like here we had an x value of +7 and it was x minus 7. It's like the opposite. -14 here means the point has a +14. But y, we do not flip, right? Oh, and I should have just been using this example too. So if the y is a -4, we leave it as a -4. Here our y is +8, so it's 5,8. So that's the only weird thing, is that the x flips the sign because there's a minus in the formula. All right, slope is that number in front of the parentheses, in front of x. And the point, we flip the sign on x and leave the same y. All right, slope is that number in front of the parentheses, and then we flip the sign for x and we keep the same y. So it'd be -9, -4. All right. Hopefully that all makes sense. So let's try graphing these then in point slope form. So we got to make our axes on this. So let's start in the middle of the page, make some beautiful axes. Use your straight edge, please. Doesn't have to be a ruler, but it needs to be something that you can follow along to make a decent looking graph. Okay, same with this. I may as well make them both while we're doing this. All right, so we got some axes to start with. Excellent. So now we need to pick what our point is. Remember, we flip the y. The sign of the y is flip the x. Opposite sign for x, and then the same y. There we go. And then the slope is positive, so it's going to be up to, and then we always move over to the right. Okay, let's try that. So the point, we go back 1 for x, -1, and then down 2 for y. -2 for y. There's the point. The slope is up 2 blocks, over 1, 2, 3 blocks. And over is always to the right. And then that should be it. We got the point, we got the slope. Make sure your line extends to the ends of the axes. It shouldn't just be like between the 2 points. It should go all the way through, because there are other points that are also on this graph. Well, that's not too bad. Let's try another one. So this one, the point, we're going to do opposite of x, so that's +4, same y that's out here. The slope this time is negative, so that's going to be down 1, but always to the right. The negative only moves to the top number. All right, so our point, we go over to 4 in the x direction, then up 2 for y, so it's right there. And then our slope is down 1, oh, I'm out of graph. Now, you can estimate where that might be, down 1, right 3, but you can sort of make the slope, I guess, you know, I emphasize, always put the negative on the top. If you flip it, you could go up 1 and then left 3, I guess. Up 1, left 3. I don't like doing that normally, but it makes it so that I can see that slope is still down 1 over 3, right? If we move to the right as normal, it still works. So you can either sort of estimate where it is. We could also have changed where our axes are. I just put them in the middle, but let's connect these with a beautiful line. So it goes to the 0.42 and it has slope of -1/3.